I'm Cheryl Leach. In this problem, we would like to evaluate the trig function values of 2 pi over 3 without using a calculator. Now, it's not possible to know all the trig function values for every angle. There are infinitely many angles. However, certain angles are very common, and it's nice to be able to evaluate those trig function values without needing to pull out your calculator every time. And so that's what we're going to do with 2 pi over 3. Now, there are a variety of ways that you can use to help you remember some of these common angles. One way is to look at two right triangles. If I have a right triangle that has an angle pi over 6 and pi over 3 as the acute angles, that's a 30-60 degree right triangle, I know that the sides will have a length 1, 2, and root 3. In a similar way, if you have an angle of pi over 4 or 45 degrees, the sides of the triangle will be 1, 1, and the square root of 2. And then we're going to throw in a number line just to help us get those quadrantal angles. Well, that's one way you can figure out all the trig function values of an angle that's pi over 6, pi over 3, pi over 4, or any of those quadrantal angles. Another option, if you don't like the right triangle method, is to look at this table. Now, in this table, I'm telling you what all the different angles are and what the sine values are. And you can see a pattern. For the sine of 0, it's root 0 over 2. For pi over 6, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2. If you want the cosine, you're going to move backwards across this table. Now, this table doesn't tell you anything about the tangent or any other trig function values, but you can use the relationship between those trig function values and sine and cosine to get your answers. There are also more detailed tables that you can use, or maybe a unit circle. So, what method would you like to use? The choice is really up to you. My personal favorite is the right triangle definition, so that's what I'm going to be using in this problem, but feel free to use whichever method you like. Okay, so back to the problem at hand. I want to find out, first of all, what the sine of 2 pi over 3 is. Well, the first problem is if I look at my right triangles in my Cartesian plane that I have up here, I notice 2 pi over 3 is not listed. Okay, so what do I do about that? Well, let's take a look at what that angle 2 pi over 3 looks like. I'm going to draw a Cartesian plane, and I'm going to draw an angle whose measure is 2 pi over 3. Now remember, halfway around is pi, so 2 pi over 3, the terminal side will be in the second quadrant. So it's going to look something like this. So that's my angle 2 pi over 3. I'm now going to mark down something called the reference angle. The reference angle is the acute angle that you make with the terminal side of your angle and the horizontal. So I'm talking about this angle right in here. And again, because I know halfway around is pi, or 3 pi over 3, I know the measure of this angle. It's pi over 3. Now, if you can kind of envision taking this angle and flipping it back into the first quadrant, you'll notice that all the ratios that I'm going to be using for my angle pi over 3 will be the same as those of 2 pi over 3. The only difference is that some of the values will be negative, where pi over 3, they'll all be positive. So, what does that mean? Well, it means I can use pi over 3, which is in my triangle here, to calculate all the different trig function values of 2 pi over 3. Then I just have to put the right positive or negative sign with it. So let's go ahead and see what happens. So here is pi over 3, which is my reference angle. I know that the sine is the opposite over the hypotenuse. So the opposite over the hypotenuse is going to be the square root of 3 over 2. So I have the square root of 3 all over 2. Now I have to determine whether I want that to be a positive square root of 3 over 2 or a negative. Now, one little trick that will help you remember this is by looking at a little trick that says all students take calculus. Now, how is this helpful? Well, in the first quadrant, all of my trig function values are positive. That's what the A stands for. In the second quadrant, S stands for sine. So the sine and its reciprocal cosecant are positive. Everything else is going to be negative. Now that should make sense because remember what the sine is. It's the y-coordinate over the hypotenuse. And the y-coordinate will be positive in the second quadrant, so is the hypotenuse. Okay? And the same thing will happen with the reciprocal. Okay? In the third quadrant, the tangent and its reciprocal cotangent are the positive ones. And in the fourth quadrant, it's the cosine and its reciprocal secant that are positive. All right, now based on this information, I'm in the second quadrant. So the sine and the cosecant should be positive. So my sine is square root of 3 over 2. All right, let's keep moving. Next, I want the cosine of 2 pi over 3. So I'm going to use pi over 3, my reference angle. The cosine is the adjacent over the hypotenuse. That gives me 1/2. But I'm in the second quadrant. The cosine's negative in the second quadrant, so it will be a negative 1/2. So the cosine of pi over 3 is a positive 1/2, but the cosine of 2 pi over 3 is negative 1/2. That negative is the only difference. Right? Moving forward, let's do the tangent of 2 pi over 3. Again, I'm using my reference angle of pi over 3. Tangent is the opposite over the adjacent. So the opposite is root 3, the adjacent is 1. So I've got the square root of 3 divided by 1, which can be reduced to the square root of 3. Now let's be careful. I need to worry about the sign. Is the tangent positive or negative in the second quadrant? It was negative, so this should really be negative square root of 3. Okay, moving on. Cosecant. Cosecant is going to be the hypotenuse over the opposite. So the hypotenuse is 2, and the opposite is the square root of 3. Okay, now let's check out the sine. The cosecant is the reciprocal of the sine, so that means it's going to be positive. So 2 over root 3 is my answer. Secant. There's my reference angle. I'm going to be taking the hypotenuse over the adjacent, so that's 2 over 1. Okay, but remember, I'm in that second quadrant, so the secant is going to be negative. So I have a negative 2 as my result. Last one, I need the cotangent of 2 pi over 3. One more time, I'm looking at the reference angle, and I'm going to be taking the adjacent over the opposite. So that's 1 over the square root of 3. So I've got 1 over the square root of 3. Don't forget to check that sign. In the second quadrant, my cotangent is going to be negative. And as a final check, remember that the sine and cosecant are reciprocals. Are they reciprocals? And how about the cosine and the secant? They should be reciprocals as well. And they are. And the same thing is happening with the tangent and the cotangent. So I'm confident in my answers. I hope this was helpful. Thanks.